The next speaker is Alireza Geranmayeh Kashani from the Department of Civil, Construction and Environmental Engineering. The title of Ali's talk is Fighting Tornadoes with Lasers. Thank you.
The massive tornado that hit our towns 2 years ago completely changed my PhD path. It was the first time ever I saw how destructive a tornado can be. It was really unbelievable. With a quick search, I realized that annually over 1,000 tornadoes hit the United States and caused billions of damage loss. As a civil engineer, I started asking myself, how can we improve our design and construction to decrease the tornado damage? Or more simply, how can we fight tornadoes? The problem is that specific characteristics of tornadoes, such as rotating winds and different wind speeds in short distances, have made the structural design for tornadoes very difficult. An effective solution to increase engineering knowledge about tornado loads and then improve design is the assessment of damaged buildings in the path of tornadoes. During the last 2 years, I was involved in several damage assessment investigations after tornadoes in Alabama, Oklahoma, and Missouri. But during these investigations, I found that conventional approach of sending engineers to inspect damaged areas is not very efficient. It needs a coordinated team of experts, room and board, transportation, and site access. It is also very time sensitive because cleanup efforts begin very soon after tornadoes, and it's really hard to investigate all damaged buildings before they get manipulated. So, seeing these issues, I decided to work on a more efficient damage assessment approach. How? With lasers. In my PhD, I aim at leveraging laser scanning technology into post-tornado damage assessment. Laser scanning is a sensing technology used to save the geometry of objects in 3D and with high precision. So as you can see in this image, I propose to use laser scanners after tornadoes to rapidly save the geometry of damaged areas in a virtual 3D environment. The result is a 3D point cloud, which simply means a set of millions of points with 3D positions. In this research, I also developed computing methods that enable to automatically identify building components in scans of damaged areas and automatically evaluate the amount of damage. This automated method should hopefully help engineers to conduct more efficient, more reliable, and faster damage assessment after tornadoes. And I believe this will enable them to learn more about tornado loads and design stronger structures in future. So if next time you see more buildings survive after tornadoes, please remember this presentation about fighting tornadoes with lasers. Thank you.
And now the person that you selected as your favorite, the People's Choice Award. From Civil Construction and Environmental Engineering, Alireza Kashani.